In the south of England, the University of Southampton is a place where students, researchers and intellectual leaders come together in the spirit of partnership.
One of the features of the University of Southampton is that we have strength across a broad range of different subject areas, and because of this we're particularly keen on having collaborative research projects. And this is the case within mathematics. We have pure mathematicians working with applied mathematicians on solving some of the important problems of today and bringing to bear the advanced techniques they have on looking at these problems.
My research interests are in the application of mathematical models and methods in molecular and cell biology, and specifically to stem cell biology. Molecular and cell biology experiments now produce lots and lots of data. Lots of these problems of understanding this data are very difficult with traditional techniques. So I began to reach out to some pure mathematicians to see how we could apply methods and techniques which were derived in pure mathematics to these applied problems.
Ben approached me because he was working on experimental biology, was generating a large amount of data. I was looking at new tools and new ways of analyzing this data. He thought I would be able to help because my background is in pure mathematics, and maybe we could use some of the tools we had used to analyze this data. We were successful in establishing a common framework of how you can understand symmetry in complex networks. And this not only applied to networks coming from biology, it could apply to any network representing any complex system. For example, the power grid network. And this is precisely the project we are working on right now here at the school.
So at first the problems which arise in molecular biology and, for example, in the electrical power networks are very different from each other, but actually they're very similar. So for example, complex biological data sets you can often represent as networks, and you can represent the electrical power grid as a network as well. And it turns out that they have very similar properties to each other. Southampton fosters a very collaborative environment, and this kind of collaboration is encouraged.
It's quite unusual to find a pure mathematics department where the ongoing research and also the interests are in a more applied side. I think it's a very collaborative environment. There is a lot of communication between different groups and a really commitment to apply different techniques, even new techniques, to more applied problems. And therefore I found it a great place for me to work in.
Collaborations with pure mathematicians are really important, but in any good mathematical modelling process we have to draw on all sorts of mathematics: applied mathematics, pure mathematics, statistics and operations research. And here at Southampton we go and have a collaborative effort through a system called symbiosis, allowing us to go and interact with our engineering colleagues both in nanoengineering and in bioengineering. It's been very effective.
We're very lucky here at the University of Southampton to have particularly low barriers to collaboration between departments and disciplines. As an engineer, pretty much everything I do is underpinned by mathematics, and engineers in general can never get enough mathematics in order to solve the problems of interest to us. So it's of great value to us to have forged extremely strong links with mathematics, operations research, applied statistics, in order to bring that expertise to bear on engineering problems, particularly ones of industrial relevance.
In order to have problems to solve that are really useful to the community and to the country, having industrial partners involved in identifying problems, motivating what problems we should solve and what answers are useful is very, very important to us.
The philosophy we have in the kind of research we want to do is a common theme. We want to find our research problems in the real world, develop our new methods and then evaluate them and improve them through using them in real life situations. Statistics generally does look to the outside world and has worked on many areas. One example is work on engine mapping with the automotive industry. There we were able through our work to reduce the time it takes to get the engine out from 2 weeks to only a few days, with very obvious impact in economic terms for the company.
By integrating complex mathematics into groundbreaking technology, the leading research of Southampton's mathematics department continues to spearhead dynamic new projects.
Building on symbiosis, we've recently launched the Southampton Initiative in Mathematical Modelling, which brings together teams of mathematicians to work on interdisciplinary problems. And this is a prime example of how mathematics underpins this sort of work. And it's this kind of work that puts Southampton University at the forefront of research in Europe.